So today we are going to talk about density and states of matter. If you remember, we talked about density in the previous classes. Actually, we talked about mass first, volume second. What is density in natural science? How do we define the density in science? Sometimes we define the density, okay, in our words, but how do we define in a scientific perspective? Okay, that's what we are going to talk about. Quickly, I'm going to do a quick revision I'm planning to do today, and then I will talk about the relationship between the states of matter and the density. We know what is states of matter, okay, before, and then I'm going to give you one specific example and then details. That's what I'm planning to do today. And grade 8 natural science, term 2 topic, density and states of matter, today's topic, okay? And then if you want to look at the slides, if you need slides, and then the class video, it's going to be on Google Classroom, okay? And let's look at the content, okay? Content is not too long like before, you know that, okay? Because I'm going to talk about a specific example today. I'm going to explain you how does it happen, okay? I discussed before, not in details. Today it's going to be in details. We are going to dig it into the science behind it, okay? Density, mass, and volume, okay? The density of a material describes the amount of mass given in a volume of that material, okay? Definition of density of a material, the amount of mass in a given volume of that material. So which means that to be able to understand density of a substance, you need to talk about mass divided by volume of the substance, okay? And then mass divided by volume of the substance is going to give you, it's going to give you the density of the substance. And then if you remember that we are using some units, okay, for mass and volume, okay? What are the units that we use for the mass and what are the units that we use for the volume? Let's discuss one more time, okay? The units are very important, okay, to be able to understand scientific concepts, okay? We said the grams, okay, for example, grams, and I'm just going to write in long, okay, kilograms, okay, for the mass, okay? These are the two important units that we use. For volume, we gave lots of examples. For example, we said that cubic centimeter, okay, centimeter, okay, centimeter, by the way, centi. Okay, I'm trying to fix it. Okay, or cubic decimeter, cubic decimeter, okay, decimeter. That's how we can put it. Or there is liter and then milliliter. Okay, can I just put those ones, liter, the symbol, and the milliliter like this, okay? Liters and milliliters. And then we talked about the relationship, if I'm not mistaken, the liter and milliliter. We said that 1 liter is equal to 1000 milliliters. And we also talked about the relationship between the cubic centimeter and the cubic decimeter. Cubic decimeter, okay, is 1 cubic decimeter is equal to 1000, okay, cubic centimeter. And we said that actually cubic decimeter is a volume that's equal to a liter, okay? 1 liter is equal to 1 cubic decimeter, okay? They are equal to each other, okay? So I can also say that 1 milliliter is also equal to 1 cubic centimeter. Yes, they are equal to each other. What about the relationship between the units of mass? Okay, 1 gram and the 1 kilogram. Okay, I always choose the easy one. Okay, talk about the easy ratio. Easy ratio is bigger to smaller. Okay, so 1 kilogram is equal to 1000 grams, or 1 gram is equal to 1 over 1000 kilograms. Okay, it's better to say, I think 1 kilogram is equal to 1000 grams. Okay, you already know about this. You are going for shopping, sometimes you buy Coke, okay, you talk about how many liters and then you talk about the price, etc. And then when we talk about the units for the density is that, okay, we said it's going to be grams per centimeter cube, okay, grams per centimeter cube, okay, cubic centimeter, or we said that it can be kilograms, okay, kilograms per cubic decimeter, okay. So which means that if I use the mass in grams, the volume should be in centimeter cube. If I use the mass in kilograms, the volume should be decimeter cube. Okay, that's how we can identify the density. So which means that this one tells me that if you take 1 centimeter cube of a substance, how many grams is this? If you take 1 decimeter cube of substance, how many kilograms is this? That's what we call density, okay? If you take a unit, 1 unit means 1 decimeter cube, 1 unit of volume of substance, okay? Object. How many kilograms and grams is this? Is the density, okay? That's how we put it in this way. And if you remember the definition of mass and volume, okay, you remember the definition of mass and volume. What was the definition of mass? Amount of matter in a substance, okay? How many atoms is your body composed of? If you have a board marker or if you have a USB, USB is composed of how many atoms, okay? That's the mass. And the mass in grams and kilograms. What about the volume, okay? Volume is the space occupied by an object, okay? Space occupied. And then we talked about how to calculate the volume of defined shapes, okay? And we talked about how to calculate volume of undefined shapes, okay? If you have a piece of stone, okay? If you have any shape that you cannot find the measure the height and the width and the length, okay? So what you do is that you use the displacement of water. I gave you one example if you remember, okay? And then today we are going to talk about density and the states of matter, okay? What about density and states of matter? In general, gases are less dense than liquids. Liquids are less in general, mostly like this, okay? Is there an exception? Yes. Okay, what is the exception? H2O molecules. When H2O molecules in solid phase, okay, they have less density than liquid phase at 4 degrees Celsius, okay? That's what I'm going to discuss, show you today, okay? There's always exceptions, especially in chemistry, okay? This is one of the exceptions, is that, but in general means 99.999% of the substances like that. We can say that, okay? And the gases are less dense than liquid. And liquids are less dense than solids, okay? What is an exception? As ice, less than water, okay? Normally, what's supposed to happen? Water, the liquid is supposed to be less than solid, okay? But in this case, the solid has less dense. That's why ice floats on the liquid, okay? For example, if you go buy Coke, okay, and then put ice inside, and you are going to see that the ice pieces are floating on the, okay, on the surface of the water or the fizzy drink, okay, cool drink. Actually, cool drink is made up of water, mostly water, okay? That's why I'm giving you this example, okay? And then if you want to have a glass of cold water, what do? You just fill it in tap water and then you add some ice on it, and then you see that the ice floats on the top of the water, okay? But it's not supposed to be like that, okay? It looks, oh, ice floats on it. Yes, we know that, but it's not what happens with all the other materials. It's special for H2O molecules. It's special for water. If I don't have water, if I have something else, what will happen? Okay, the ice, not the ice. So I'm talking about solid particles. Okay, the solid particles supposed to go to the bottom sit in the bottom. Okay, so that's what we are going to talk about. Why it's like that? Why water is special for us? Okay, before that, I just would like to show you some density examples. What we discussed before. And we already discussed the definition of density. This density of a material describes the amount of mass in a given volume of that material, okay? And then we use this formula. You remember this formula, density is equal to mass over volume. For example, you have a piece of magnesium. What is magnesium? It's a metal, okay? As you can see that one of the properties of metal is they are shiny. They are like, they are in gray color, they are shiny, okay? And then I can give you too many examples, okay? So, magnesium, okay? You have a piece of magnesium and then you know the volume of the magnesium. It's 10 centimeter cube, and the mass, you put it on scale, and when you put it on scale, you saw it's 92 grams. It's a small piece, okay? Small piece, 92 grams. And then how can I calculate the magnesium, the density of magnesium? Very easy. What we need to do is that, okay, density is equal to mass over volume. Okay, what is the mass? 92 grams, okay? Divided by volume is 10 centimeter cube, okay? So 92 over 10, okay, I can show you something. with your permission, I'm going to go out from this. Can I just clean up this? Okay, I just want to start something. I hope that okay, it's working now. Okay, so I'm just going to start something now, and then you're going to see on your screen. So currently what you can see on your screen, so 92 divided by 10, okay? Now what you are going to see, scientific calculator, okay? 92 divided by 10, I'm going to show you, okay? 92 divided by 10, what is it equal to, okay? So if I just 9.2, okay, 9.2. Let's go back to the slides. 9.2, and then what is the unit? How do I know the unit? Okay, look at here, grams divided by cubic centimeter, okay? Grams, this one means grams divided by centimeter cube or cubic centimeter, okay? This way of representing and this way of representing is same, okay? So which means that if I cut a piece that's equal to 1 centimeter cube, okay? 1 centimeter cube. What will be the mass of this piece? 9.2 grams. I'm using my mouse to write, sorry. Okay, 9.2 grams. Okay, that's what we call density. Any questions? No? Okay, let's move to the next one. You know this stuff, okay? I'm doing the revision because this is important, okay? And the next one, another one, okay, from previous slides. I copied this one from previous slides. And you have aluminum, okay? Aluminum is a metal, okay? And then they are in gray color usually, and they are hard substances. Aluminum is actually is not hard like other substances, okay? Other metals, I'm trying to say. And then when I look at here, imagine that you measure the volume, okay? What is the volume of it? Okay, is equal to 10 centimeter cube. And then you put it on scale, and then you measure the piece of aluminum is 142 grams. And then how can I calculate the density? Mass. What is the mass? Mass is here. Mass, okay, mass is 142 grams divided by 10 centimeter cube, okay? Let's go back to our calculator. 142, 142 divided by 10, okay? That's going to give us 14.2, okay? It's going to give us 14.2 grams, okay? 14.2 grams per cubic centimeter. So which means that, I'm going to repeat this one more time in another example. If you cut out a piece, and that piece is 1 centimeter cube, okay? Cubic centimeter in volume, okay? The mass of this piece is going to be equal to 14.2 grams, okay? That is what we call as density. What is density definition? The mass of unit volume, okay? Mass of, what is unit volume? Unit means 1, okay? Our unit here is that for volume is centimeter cube, unit volume means 1 centimeter cube. So what is the mass of 1 centimeter cube? 14.2 grams. 2, 24.8, and then 28.4 grams, okay? And then it carries on like that, okay? Multiples of it. And another example, okay, from previous, okay, we also discussed examples like this. You remember that, okay? I'm just going to do revision again, okay? So if you have a identified shape like this is what we call as cube, okay? Cuboid, cuboid, okay? You can give different names, okay? What is the name of this? Okay, can I just show you different? Okay, there is no need, okay, let's carry on. Cuboid, cube, okay? And then how do we calculate the volume of this? If they give you the sides, measurements of size, the width, the length, and the height, okay, all of them are equal to each other. So the volume is equal to, one is 2, and height is 2, okay? 2 centimeter cube times 2 centimeter cube times 2 times 2, 4. 2 times 4, 8 centimeter cube, okay? So what is this? Our volume, okay? Now the volume of this structure is 8 centimeter cube, 8 centimeter cube, okay? And what about density? Okay, what about density? Density is equal to mass over volume, okay? What is the mass of this substance? 16 grams. You put it on scale and then you measure the mass, okay? And then you get 16 grams. And then what is density? Mass over volume. And the mass is equal to 16 grams. And then we calculated the volume here. Okay, look at the volume here. Yes, somebody asked why the 3 is negative. Okay, why the 3 is negative? The power negative, which means, okay, I'm going to explain now. Okay, 16 divided by 8. Oh, very hard question. 16 divided by 8, 2. Okay, 2 grams per centimeter cube. Okay, actually, the unit, as you can you see the unit here? Okay, grams per centimeter cube. Okay, grams per centimeter cube. Somebody asked, why do we write in -3? Okay, maybe you don't know this. You don't know this. Okay, that's how we explain the. You put the units in FET phase. Okay, you are going to see this in grade 10, 11, 12. Okay, so this one is equal to this one actually. Okay, grams times centimeter cube power -3. Okay, these two is the same thing. Okay, there is no difference at all. Okay, this one means that power -3 means that it is 1 over cubic centimeter. Okay, 1 over cubic centimeter. This two is same. Okay, this two is same. So if you want, you can write down like this. I don't mind. Okay, you can write down like this. But in grade 10 and 12, we have to write down like this. Maybe you didn't see this power negative power. Okay, don't forget. Okay, don't worry. Okay, what you can do, you can just write grams per centimeter. That's also perfect. Okay, so power -3 means the same thing as this one. Okay, it's same as that. Okay, that's how we represent in maths. Okay, that's maths. If you didn't see this, don't worry, you can just write down grams per centimeter cube. That's 100% correct. Okay, and states of matter. States of matter. You remember the states of matter that we discussed in the previous classes? Yes. What is states of matter? Solid, liquid, gas. Solid, liquid, gas. And then when you apply and okay, when you apply heat energy, so what happens? Solid, it liquefies. Okay, melting, goes into melting. If you apply more heat energy, okay, to the liquid, it will evaporate. At the same time, after a point, what will happen is that after this, what will happen is that, and then when it comes to a point, that's what we call boiling point. That's what we call temperature. That's what we call temperature. If it comes to 100 degrees Celsius for water molecules, and then it will start boiling, and then it will turn into gas totally. And then you take the steam, okay, you keep it in a container, and then you cool it down. How can I cool down that steam? Okay, you put it in a container and put it in a fridge, and then it's going to start liquefying. That's what we call, actually, I like to say, condensation or condensing. And then it will turn from gas into liquid. And then after that, you take the liquid and put it in freezer. You need more colder, okay? You need more lower temperatures. And then you put it in freezer, okay, and then it gets colder, 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 colder. After a point, that's what we call freezing point. For pure water at sea level, it is around 0 degrees Celsius, okay. When it comes to that point, what will happen is that it will start freezing or solidifying. I like to say freezing anyway. And when we look at the particles, okay, when we look at the particles that makes up, okay, the particles that makes up the matter in different phases. I'm going to talk about this. And the molecules held in fixed pattern and but vibrating. You can see that when the particles in solid phase, they're very close to each other and then vibrate at fixed positions, like vibration of a phone. Okay, they don't move fast, they move very slowly. They will never ever ever stop moving. Okay, we know this. Okay, so because if they stop moving, the temperature will be absolute 0. Okay, so the volume will be equal to 0 in that case. Okay, we just assume that the particles, they will never, even it is very cold, okay, it doesn't stop moving. Okay, at least they vibrate at fixed positions. That's what we know from science perspective. And when we look at that, when you apply heat energy, and this heat energy is absorbed by the particles, they will start moving faster. And then what happens is that molecules are packed close together in a random fashion, free to move. Okay, they slide over each other, they move faster than solid phase, and the particles, they have more space between them because they move faster, they vibrate faster at their positions. Okay, and then when you apply more heat energy, that heat energy is absorbed by particles, and then they have too much energy, they get crazy. Okay, and then molecules widely separated and move at great speed. This one is speed, by the way. Okay, there's a mistake here. Okay, this one is speed. Okay, at great speed, which means that they have the highest speed, they move fast, they want to be free, there is too much space between them, and then that is what happens to the particles, okay, when they change the state, okay, when they change from solid into liquid, liquid into gas. And there is one more point that I forgot to discuss is the subliming, okay, it's what I like to call is sublimation. I don't know why they put it, okay, sublimation, it's okay. I like to say sublimation. What is sublimation is that sometimes for some chemicals, okay, it's specific for some chemicals, they can turn from solid into gas directly. I can give you one example. It's carbon dioxide. When you freeze carbon dioxide, it turns into crystals, solid crystals. And when you leave it outside, when it starts melting, actually it doesn't melt, it goes into sublimation. So the solid carbon dioxide turns into gas directly. That's what we call it as dry ice. Okay, you heard about this maybe. There's something called dry ice. They use it for ice cream people, okay, selling ice creams. Especially they are using dry ice if they don't have freezer, okay. And then what is the importance of this dry ice? It's very low, it has very low temperatures, it keeps cool your stuff, plus it doesn't get wet, okay. That's why we call it dry ice, because solid carbon dioxide, that's solid carbon dioxide, directly turns into gas, okay, and it doesn't get wet, the material that you are keeping in it, okay. And the opposite of sublimation, you remember this also, opposite of sublimation. What is the opposite of sublimation? Is deposition, okay? Deposition is what happens is that gas can directly turn into solid. Yes, we can talk about the similar substances. And what about density? What about density, okay? So what happens is that, okay, what happens is that when you look at this diagram, this is another diagram, okay, when it changes from solid into liquid, liquid into gas, what happens to these four particles? Can you see that? The same four particles, okay, the same four particles, they occupy more space, okay? More space, and then what happens to the density? Density will increase, okay? If it is the same amount of particles, the mass is same. If the mass is same, and if you increase the volume, what will happen? Okay, and then it will be lighter, okay? And then that's what we call as the density decreases. Why? The particles are moving away from each other. Trying to move to the next slide. And this is another example that you can see. For example, A is solid, B is liquid, as you can see, more space, and C is, there is less space, okay, more space than B. So this one is A is solid, liquid, and gas. If you want to identify the phase of each, same particles. And if you take these 5 particles here, can you see the space occupied by particles? And the 5 particles here, this one is a little bit more than that. And when we look at the same 5 particles, when they turn into steam, okay, turn into gas, what will happen? They occupy more space and the density of particles decreases. So what we expect is that when the density of particles changing from solid to liquid, liquid to gas, density decreases. Or another way around, opposite way, okay, when the substance changes the state from gas into liquid, liquid into solid, like cooling down, the density increases, okay? That's what we expect is the general trend, okay? We discussed by using some diagrams, okay? I just want to take your attention to this case study from a textbook. Solid water is less than the liquid water. Oh, this is strange. Why? We just said that solid particle has, if it is the same, okay, if it is the same substance, as you can see, it's solid water and liquid water, it's the same substance. What we are expecting is that when it is in solid, it's going to have more density, but solid water has less density than liquid water, okay? Ice floats on liquid water. This means that ice, a solid, is less dense than water liquid. Yes, one example I gave you is, what was that example? If you have cold water, okay, if you have water, tap water, and if you add ice pieces, okay, pieces of ice on it, and then it floats on it. It's not supposed to float, okay? And then This is very unusual. Yes, we just discussed that. It's not possible. So how does it happen? Normally, the solid state of a substance is more dense than its liquid. Its particles are closely bounded together. It occupies less space and move around less. And this is because the energy has been removed from the liquid. Yes, cool down. When the water liquid cools down, its particles start moving closer. And then, however, as water starts to freeze, the particles move apart again very slightly. Why? Because of its chemical properties. That's what I call intermolecular forces, if you want to know the name. And I can give you more specific example. That's what we call hydrogen bonding. Okay, that's what we call as hydrogen bonding. Okay, that's what we call as also hydrogen bonding. Okay, hydrogen bonding. So because of the chemical bond inside, okay? And you can think of it like a crowd of people staying close together, pushing outward slightly with their elbows, okay? The people are still packed closer together, but they are pushing each other slightly apart. So when the water starts freezing, it floats again. This layer of ice keeps the water underneath it slightly warmer so it does not freeze. I discussed this in the previous classes. I said that if it is the water is like other substances, okay, solid has more density. The solid has more density than liquid. What will happen? So the water inside of the lakes and rivers, it will start get freezing. Okay, it will start frozen from bottom. If it starts frozen bottom, and then it can kill the plants first of all, and then you can see that at the bottom of the lake will be frozen, and on the top there will be, okay, and then the top point, if it is frozen, and everything in the all aquatic life, the fish, animals, other animals, and then the plants will be frozen at all during winter. And then after winter we will not, okay, we will not see any aquatic life living after the season, okay, cold season, okay. And then what I call this one is the miracle. It's a miracle actually, okay. And that's why the animals living in the water, they can survive during the winter, okay. And what do you think would happen if the ice froze from the bottom upwards in lakes and rivers? And then it can kill everything, okay. It will kill everything. And there is, okay, there is an explanation here. Okay, this is the graph, density versus temperature. Normally graph is supposed to be like this, okay? All other substances like this. So if it is cold, solid, it's supposed to have the highest density. But when we look at the ice, I'm not going to give you more deeper examples of this. It's just to show you how the graph looks like. Okay, normally it's supposed to go up. But for water, because of its spatial chemical properties, it goes down, the density decreases. That's why when we look at, this is 4 degrees Celsius, okay? And the 4 degrees Celsius is the highest density of H2O molecules. So this is actually 4 degrees Celsius, okay? It's from a resource, okay? This is 4 degrees Celsius. Let's say it's 4 degrees Celsius. So when the water is cold, it has higher density. If you mix with warm water will go up, because warm water, can you see that warm water? Density decreases, 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 decreases. If the density is lower, it goes up. We discussed this before, okay? And then if you put ice has lower density than warm water and cold water, okay? So what happens is that basically what I'm trying to say is that, okay, density of water, okay, density of water, okay, density of water decreases when it gets frozen, okay. And then I found this from internet. You can find too many explanations like this. Let's read it through. Okay, I like this. Why does ice float on water? Okay, normally what is supposed to happen? I like this diagram. That's why I took this. Okay, to show you. Normally, if it is iron, okay, liquid iron and solid iron, it sinks to the bottom because solid iron is stronger than, sorry, higher density, having higher density than liquid iron. But what about H2O molecules? When the H2O molecules, the water molecules, when they are frozen, they have less density than water. That's why it floats on it, okay? So if you place a piece of solid iron in water, actually it's supposed to be iron, okay? Liquid iron. Let's imagine that liquid iron, sorry. They made a mistake here. And it will sink. It's supposed to sink. And then it's because of the fact that, okay, and then what happens is that the solid ion has more density than liquid ion. But when we look at ice, okay, why? Because why it flows? Because of the hydrogen bonding, okay, because of its spatial chemical property, okay. And then that is why the aquatic life, okay, aquatic life can survive during the winter. And then what happens is that actually, imagine that, okay, I'm just taking you to a slide. We are almost done, last 1 minute. Imagine that this is lake, okay? So this is the surface of the water, and then when the outside is like very cold, okay, it will get frozen from top, okay? So it will be like a isolation layer, and then in the bottom there will be a water around 4 degrees Celsius, okay? And then these ice particles here, they have less density than, okay, less density than 4 degrees Celsius water. And then the aquatic life, the fish and the plants, okay, can survive during the winter conditions. Otherwise we will never ever have nothing left, okay, after the winter, okay. That's what I want to talk about today, okay. Spatial case of water. I'm just going to get attendance before you go. Please don't go, do not go anywhere. I'm taking attendance. Jazakallah for attending the class, okay. So please do not forget to